Hello everyone, it's Muad with you again, and today we're going to start with Calculus 1. And the first topic that we're going to discuss is limit and continuity. We're going to start with the concept of limit. Okay, so let's say we have a function f is defined for all x's in an open interval containing a. A is can or cannot be defined, it doesn't matter. Okay, so if we take values of x very close to a, approaching from both sides. So let's say a is equal to 2. So we're taking values of x really close to a, which is 2, from both sides. Let's say x is 1.99, this is from the negative side, and x is equal to 2.01, this is from the positive side. So the value of x, f of x, and f of x should be getting closer also for f of a as we're getting closer to 2. This is the concept of limit. So we can say by making x sufficiently close to a, then we say that L, which is the value of this limit, is the limit of fx as x is approaching a. So we can read that as limit of fx as x is approaching a is equal to L. Okay, now how can we know if a limit exists or not? A limit exists if and only if both corresponding one-sided limits exist and are equal to each other. So there's two conditions. Both one-sided limits exist and they are both equal to each other. Let's go back to the example of 2. This is 2 and we're approaching 2 by both sides, positive side and negative side. So a limit exists only if we're approaching from both sides and both of them exist and both of them are equal to each other. So we can see here limit of fx as x is approaching to a from the negative side equal to limit of fx as x is approaching to a from positive side, and they are both equal to each other. Then we can say limit of fx as x is approaching to a is equal to L. So this means that there is limits from both sides, positive and negative, and they are both equal to each other. Limit as x is approaching to a from negative side is equal to limit as x is approaching to a from positive side. Let's take this example. Evaluate the limit of x squared minus 4 over x minus 2 when x is approaching to 2. There are many ways to evaluate a limit. We're going to discuss 3 ways in this video, and later on we're going to discuss more ways to evaluate a limit. The first one is using a graph, and the second one is using a table. So now we're discussing approaching to 2 from the negative side. We can see here on the graph, as we're approaching to 2 from the negative side, from this side, the value of fx is also approaching 4. So we can say limit of fx while x is approaching to 2 from the negative side is equal to 4. And using a table, if we take close values of x to 2 from the negative side, which are 1.1, 1.99, whatever, as we're getting closer to 2, we are also getting closer to 4. So we get the same result, which is limit of fx as x is approaching to 2 from the negative side is equal to 4. Now let's discuss approaching from the positive side. As we can see here also, as x is approaching to 2 from positive side, the value of fx is getting closer to 4. and using a table as well. 2.1, if we take x, values of x closer to 2, 2.1, 2.01, 2.001. As we're getting closer to 2, also we're getting closer to 4. So we get the same result. Limit of fx as x is approaching to 2 from positive side is equal to 4. And as we discussed earlier, both limits exist from positive and negative side, and they are both equal to 4. So at the end, as a result, we can say that limit of fx when x is approaching to 2 equal to 4. However, as we can see in the graph, x, which is 2, is not defined in this function, because if we substitute x as 2 in the function, which is x squared minus 4 over x minus 2, we'll get 2 squared minus 4 over 2 minus 2, we'll get 0 over 0, which is undefined. The next way of evaluating a limit is using algebra, algebraically. We just saw that if we substitute x with 2 in this function, we're going to get 0 over 0. So we're going to use factorizing. We're going to factorize this, x squared minus 4, as x minus 2 and x plus 2. We can cancel these together, and then we're going to take limit of x plus 2 while x is approaching to 2 is equal to 4. Now we're going to discuss determining limits graphically using a given graph. Okay, so first of all, limit of fx as x is approaching to 1 from negative side. From here we go to the 1 and we approach it from the negative side from here. We can see that the value of fx is approaching 2. Then limit of fx as x is approaching 1 from positive side, from here, positive side, we can see that the value of fx is approaching negative 1. So it's equal to negative 1. As a result, limit of fx as x is approaching to 1 doesn't exist, because they do exist from positive and negative side, but the second condition, they are not equal to each other. So the limit of fx as x is approaching to 1 does not exist. Finally, he wants limit of fx as x is approaching negative 1. We're going to check approaching to negative 1 from both sides, positive side as shown and negative side. We can see that while approaching to negative 1 from positive side or negative side, we're always getting a value closer to 1. So we can say limit of fx as x is approaching negative 1 is equal to 1. Now we're going to talk about how to determine limits algebraically using a piecewise function. An easy way to handle a piecewise function, to draw a line of numbers, then putting the values 1 and 2 as mentioned in the function, 1, 2, and then we see in each area what's the function defined as. We can see that if x is equal to 1, the function is equal to 2. And we can see if x is smaller than 1, the function is defined as x. In between x is equal to 1 and x is equal to 2, which is this area, the function is defined as 4 minus x squared. And if x is bigger than 2, the function is defined as x minus 2, the square root of x minus 2 plus 1. So now we use this line of number to evaluate each limit. First of all, he's asking for the value of f1. We can see that f of 1 is equal to 2. Then limit of fx when x is approaching to 1 from negative side, from here. We can see the function fx is defined as x, so we can say limit of x as x is approaching 1 from negative side, which is 1. Then from positive side, this is negative side, this is positive side. The function is defined as 4 minus x squared. Limit of 4 minus x squared as x is approaching to 1 from positive side is equal to 4 minus 1, which is 3. So we can say that this doesn't exist because limit of fx as x is approaching to negative to 1 from negative side and positive side are not equal to each other. After that, f of 2, we can see here that there's an equality here. So if x is equal to 2, the function is also defined as 4 minus x squared. So we just plug in x as 2, we get 4 minus 2 squared, which is 0. And lastly, he's asking for limit of fx as x is approaching to 2. We're going to discuss from both sides. Positive side, where the function is defined as the square root of x minus 2 plus 1. Positive, we can say that 2 minus 2 plus 1 is equal to 1. This is 0. And from negative side, we can say that the function is defined as 4 minus x squared, which is 4 minus 2 squared, which is 0. So this is also doesn't exist because approaching to 2 from positive side gives us 1, and approaching the 2 from the negative side gives us 0. So they are not equal to each other, so the limit does not exist. Now we're going to evaluate this limit, and in this case we got two factors to cancel. So if we substitute negative 3 in the limit, we're going to have 0 over 0. So we factorize, we take 3 as a common factor, gives us x 3 times x plus 3, and if we factorize the denominator, we're going to have x plus 3 times x minus 3 as x is approaching to negative 3. We cancel these, we're going to have limit of 3 over x minus 3 as x is approaching to negative 3 is equal to negative 3 is equal to 3 over negative 6, which is negative 1 over 2, negative half. Now we've got the same function, but x is approaching to 3. If we want to draw this function, we're going to have this as the graph. So we can see if we're getting closer to 3 from positive side, from here, the value of fx is increasing to infinity. And if we're getting closer to 3 from negative side, the value of fx is decreasing to negative infinity. So limit of fx as x is approaching to 3 from positive side is equal to positive infinity, and limit of fx as x is approaching to 3 from negative side is equal to negative infinity. So limit of fx as x is approaching to 3 does not exist because both sides are not equal to each other. Later on in this course, we're going to discuss how we can figure out limits using infinities. This is the end of the video. Thank you for watching. I hope it's helpful. See you soon with another episode about Calculus 1. Goodbye.